Welcome. So now we're going to learn about another integration technique known as long division. And it's really not an integration technique so much as a rewriting technique, and so that we can change the form of an integral from something we can't integrate to something we can. Right? So you really can't deal with a quotient very well unless it happens to match the inverse trig integrals or match natural log integrating the integral for natural log, but otherwise a quotient is really hard to deal with. So we're going to use long division. So long division can be used to rewrite a rational function to one which can be integrated using the power rule and other rules such as natural log, etc. All right, so let's take a look. We're going to just do two examples. All right, so these are going to, once you get the idea, I think you'll get it right away. Right? And so when to try this, try long division if the numerator has a greater degree than the denominator. Right? You can rewrite it and then have something you can deal with. Right? So we're going to divide x squared minus 5 by x minus 4. Now there's no x term, so we're going to have to represent that with a 0. Right, everybody's got to be represented. All right, so now we're going to divide x squared plus 0x by x minus 4. So what do we have to multiply x by to get x squared? That would be x. X times x is x squared. X times negative 4 is negative 4x. And then we subtract, which means to add the opposite. So x squared minus x squared, 0x squared, 0x squared plus 4x is 4x. Right? So just be careful on your terms. You don't want to, make a mistake on the simplest thing, which is the long division, and then your integral is going to be all wrong. And what would I have to multiply the x by to get 4x? That would be plus 4. So 4 times x is 4x. 4 times negative 4 is negative 16. And subtract means to add the opposite. So 4x minus 4x is 0, negative 5 plus 16 is 11. And so now we've rewritten this. All we've done is rewritten the integral. And I'm going to put that over here, so I'm not writing at the bottom here. Here's the new rewritten integral. I'll put it in green like the other one. The new rewritten integral is, and I'm going to separate this, x dx plus the integral of 4 dx. So I'll write the quotient here, x plus 4 plus 11 divided by x minus 4. Okay, so this is the quotient, and now we're going to make that our integral right over here. So the integral of x dx plus the integral of 4 dx plus, I'm going to pull out that 11 times the integral of 1 over x minus 4. Let's use u to u substitution for the very last piece. The rest is a power rule. Right? So I'll just do that over here. So u is x minus 4. The derivative of u equals, now the derivative of x is x minus 4. Derivative of the negative 4 is 0. The derivative of x is just 1 dx. So we're going to replace the dx with du, and we're going to replace the x minus 4 with u. So now, I'm just going to write that as integral equals. The integral equals x dx plus 4 dx plus 11 over 11 times the integral of 1 over u du. And now we see what to do with that 1 over x minus 4 when it's in the format of 1 over u. Well, that's natural log. Oops, we're missing. That's just natural log, right? So we got power rule and natural log, not too complicated. So the integral is going to be x squared divided by 2 plus 4x plus 11 times the natural log, absolute value, because it's got to be positive, of u, plus c. Let's just replace the u, and now we can change to f of x. So f of x equals x squared divided by 2 plus 4x plus 11 natural log of x minus 4 plus c. And there we go. There's our final answer. I've got one more. And I gotta be honest, I wrote the equation, and I'm hoping that it's a good one for what we're working on, and I didn't make it too hard. So I made it a little harder. All right, so we're gonna divide. Again, don't have any other techniques, right? So if the denominator's got the smaller degree and the numerator's got the larger degree, go ahead and try long division and rewrite it. Right, so we're going to take 2x plus 1 and divide that into 4x to the 4th plus 6x cubed. We got no x squared, so represent that with a 0, plus 9x, and we got no constant. Represent that with a 0 as well. Actually, I'm going to change this just a little bit. I can do that. It's my equation. There. Plus 0x plus 9. Let's make that be a 9. All right. So what do we have to multiply 2x? As we just look at the first term. What do we have to multiply 2x by to get 4x to the 4th? That's going to be 2x cubed. All right, so 2x cubed times 2x would give us 4x to the 4th. 2x cubed times 1 is 2x cubed. And we subtract, which means to add the opposite. All right, so 6x cubed minus 2x cubed is 4x cubed. Well, that's worked out so well. Good. So far, so good. Plus 0x squared. We need two terms. All right, so now what do I have to multiply 2x by to get 4x cubed? We'd have to multiply that by 2x squared. So 2x squared times 2x would be 4x cubed. 2x squared times 1 is 2x squared. I couldn't ask for better numbers. All right, and so now subtract, which means to add the opposite. All right, so now we've got negative 2x squared, and we'll bring down the 0x. All right, so now what do I have to multiply 2x by to get negative 2x squared? That'd be a negative x. Negative x times 2x is a negative 2x squared. Negative x times 1 is negative x. Uh-oh. I hope it's not going to be so nice anymore. Oh well, let's just see how it goes. All right, so subtraction means to add the opposite. We've got x plus 9. Oh, that didn't work out so nice. So much for my niceness. All right, so what do I have to I still have to keep on going because I've got x and x. All right, it'd be different if that was just a constant. All right, so what do I have to multiply 2x by to get x? It's not that bad, but it would be 1/2. Right? 1/2 times 2x is x. 1/2 times 1 is 1/2. So other than the fact that we've got fractions here, but that's all right. This isn't too bad. So now we subtract, which means to add the opposite. So we have 9 minus 1/2. So that's going to be 17/2. All right, so now the rewritten equation. Actually, I'm going to put that in green actually, let me just put the quotient, and then we'll take the rewritten equation up on the other side. So we have 2x cubed plus 2x squared minus x plus 1/2. So really not too bad. Actually, this one is really not bad. Oh, excuse me. Plus 1/2 plus, don't forget, 17/2 over 2x plus 1. So except for that, not too bad. All right, so let's integrate. And so we have, I should have wrote a lot smaller here. I tell you what, if I can remember the equation, jot it on the board. Let's do the integrating on the next page. 2x cubed plus 2x squared minus x plus 1/2 plus 17/2 divided by 2x plus 1. And I'm just going to put continued on the next page. I have to learn to write smaller. I mean, look how big I wrote the question to begin with. Oops, I need to give ourselves a page. There we go. Okay, so we're integrating 2x cubed plus 2x squared minus x plus a half plus 17 halves over 2x plus 1. By the way, we can make that a little nicer. Let's make that 17 divided by 2 times 2x plus 1, right? Dividing by 2x plus 1 is the same as multiplying by 1 over 2x plus 1. So we can simplify it like that, right? And so let's split this, right? So our integral equals, we've got 2x cubed dx plus 2x squared dx minus x plus, oops, dx plus 1/2 dx plus 17 divided by 2, and we can actually, let's just distribute the 2. 17 divided by 4x plus 2 dx. Guess where we need the substitution, right? On the last little piece there. All right, so I think I can squeeze it up here. U is going to be 4x plus 2. The derivative is going to be 4 du. And you know what? I'm going to factor out the 17 to begin with. So we have 17 divided by, so we don't have to worry about him, 1 over 4x plus 1. All right, so let's rewrite that derivative. So the derivative of u will be du. Derivative of 4x plus 2 is 4 dx. Right? We don't have a 4 in the numerator, so we do have a dx if I write it in there. Let's divide both sides by 4. So now 1/4 du is dx. All right? So we'll just replace that. I'm not going to do any integrating yet. Let's just do it all at once. All right, so this is going to be, so the 1/4 can come outside the integral, right? So, because we need 1/4 du. So we can just factor out that 1/4, no problem. So now we got 17/4. And then we have 1 over u du. All right, now let's integrate. The integral is going to be, this is going to be 2x to the 4th increased by 1 divided by 4 plus 2x cubed divided by 3 minus x squared divided by 2 plus 1/2 x plus 17/4 times natural log, of course it's u, plus c. So natural log, we got 1 over u, that's natural log, right? So natural log of u. All right, now let's reduce, substitute, and let's now make it f of x. So f of x equals, this would be x to the 4th divided by 2, plus 2x cubed divided by 3, minus x squared divided by 2, plus 1/2 x, plus 17/4 natural log of 4x plus 2 in the absolute value bars, right? And then plus c, and we're done, all right? So you can take something like this, where you're like, what do I do with that? And through long division and rewriting it, turn it into something where you can use the power rule and the integrating, where you're going to get a natural log, right? So hopefully you got this technique down, and now we're going to be just doing some review, and we're going to be, so we've been looking at indefinite integration. Now we're with substitution. Now we're going to look at definite integration, which means we're going to be not getting a function, but rather getting a value. And what do we do if we had to substitute, all right, to get our integral? All right, so bye for now, and see you in the next video.